In this module, we'll be breaking down how the Formlabs Form 3 and Form 3L series printers use Low Force Stereolithography, or LFS, to produce high-quality parts by looking at the process step by step. Stereolithography, or SLA, is a style of printing that uses a combination of 405 nanometer laser light and liquid polymer resin to create a solid part layer by layer. Formlabs created a specific form of SLA called Low Force Stereolithography, which reduces the stress on parts as they build in the space. In Formlabs Form 3 and Form 3L series printers, the laser is housed in a component called the Light Processing Unit, or LPU. Along with the laser, the LPU's internal housing has a small mirror that controls the y-axis called the galvanometer, or galvo, and a parabolic mirror that directs the laser beam toward the resin tank. The laser will then pass through a glass optical window before making its way to the resin. While the Form 3 series printers use a single LPU, the Form 3L utilizes two LPUs covered by a single optical window. Two LPUs provide a small area of overlap in the middle and ensure full coverage of the resin tank. But the LPU isn't the only part of the process. After the laser light passes through the LPU's glass optical window, it will pass through the resin tank film and the resin to cure your layer to the build platform or the previous printed layer. Each layer is created in a three-part process. These steps are called the squish, the exposure, and the peel. Let's look at each step of the process. In the squish process, the build platform descends into the tank and is immersed in resin. It presses down gently or squishes against the tank film. The tank film will gently flex against the pressure of the build platform. As the LPU begins its travel across the x-axis, it will push against the tank film to create a uniform layer of resin. The space between the tank film and the rest of your part is your designated layer height. The LPU continues to move across the x-axis, using the laser to cure resin only in the areas designated by your preform file in a draw and fill method. At the end of the layer, the newly printed layer is adhered to both the tank film and the rest of your printed part, while the whole print remains attached to the build platform. All three parts, the tank, the layer, and the part attached to the build platform, are stuck together like a sandwich. Once the layer is complete, the build platform will move upwards on the z-axis, peeling the newly printed layer away from the resin tank. The tank film will flex as the layer peels away to create less force and ensure your layer remains adhered to the rest of your printed part. The LPU will rehome to the left side, and the process will begin again for the next layer. On some resins, you may also see the mixer move across the tank after each layer or every other layer. Here is the whole process in action on the Form 3 series. It moves much faster in reality. And here is the process on the Form 3L series. When you are getting ready to print your file, you will need to choose a layer height. This will determine the thickness of each layer performed by your printer. A larger layer height, such as 100 microns, will lead to faster printing, but may sacrifice fine detail. A smaller layer height will preserve fine detail and produce a smoother print, but will extend print times. Most Formlabs resins offer 50 and 100 micron layers, while some have 25 micron layer options for superfine detail, and others offer 160 or 200 micron layers for a fast turnaround on parts. The consideration of speed versus detail will ultimately hinge on the geometry of your part. Notice how in the vertical box structure, there is no improvement to surface detail when switching between a larger and a smaller layer height. The more you add an angle or curve to your part, the more improvement in surface quality you will get with smaller layers. Now that you understand the print process and layer height considerations, Watch the preform module to learn about how to set up your print for successful printing every time.